This is the video for Unit 6, Lesson 9, where we'll be able to determine the original amount from a percent change. So to think about it states, a number is increased by 25%. The resulting number is 100. Draw a double number line and write an equation to determine what the original number is. First things first, I'm going to draw my double number line. And I know that my double number line represents a relationship between two different units. So I'm going to label my percent line and my regular number line. And then to show the relationship, I'm going to plot 0. 0 and 0%. Now since we're working with percents, we all know that we can label something else right away, and that's 100%. Since it increases, I'm going to leave some space for that increase, so I'm going to put 100% in the middle. And I'm going to label also that 25% increase. When 100% increases by 25%, we end up with 125%. Now it says after that increase, we end up with 100. So the increased value is 100. And we need to figure out what the original is, which would be represented by this 100%. And based on previous lessons, we could figure out what our part and our whole is. Okay? So this percentage is our part. It's our part percent. This 100 then is also our part, but today we're going to refer to it as our part quantity because it's not a percentage, it's a measurement of a value. It's a quantity. And then our whole is our number that we're solving for. So based on this, we can write an equation. We know that 125% of our whole is 100. So 125% of our whole is 100. Let's try to convert that into an equation, okay? I'm just going to write it as percents first. 125% of our whole is 100. I know that I can't just write a percent like this. I need to put it as either a fraction or a decimal. Today, let's do decimals. Our decimal's right here. Let's move it over 2 spots to the left, and we get 1.25 x equals 100. I know that of represents multiplication, and I know that is represents an equal sign. So that's how I got my equation. Now that we have it, we can solve it. Divide both sides. And we get x is equal to 80. And that's our final answer. Now, my question is, how do we find the original value in a percent problem? How did we find it? Yes, we wrote an equation, but using our words, what did we put in the equation? We put our percent, then we put our whole, and we put it equal to our quantity. I just misspelled that. That's okay. So we know that if we put our percent as a decimal, as a decimal, I'm just going to write a note, times our whole, we're going to get our quantity, or the number that they give us, the resulting number. And that's our conjecture for today. So let's scroll down and let's copy it down. we can find the original value in a percent problem by using quantity equals percent as a decimal times our whole. And now that we have our conjecture, we can start testing conjecture number 1. 150 is the amount after a 25% decrease was applied to a number. What is the number? So how can we apply our conjecture to this problem? We can use the formula. So let's write quantity equals our percent as a decimal times our whole. So what's the quantity that they give us? How can we substitute that? We could put 150 where quantity is. That's the number that they give us. What's the percent that they give us? They give us 25%. But just like in the think about it gave us 25%. If we scroll up here, we can look. It says a number is increased by 25%. What did we do with that 25%? We added it to 100% because it's an increase. Now, if we go back down to our test of the conjecture, it's a decrease of 25%. So what am I going to do with that? I need to take 100% and subtract 25% from it. And that'll give us 75%. So now as a decimal, we need to write it as 0.75 times our whole, which we have no idea what that is. And now we can solve it algebraically. X equals 200. So does our conjecture hold true? Yes, we used the percent equation and it worked out for us. Let's check out test the conjecture number 2. It says, after a 5% pay raise, Hermione is earning $22,680 per year. What was the earning before the pay raise? So let's annotate it here. We have after a 5% pay raise, which I'm going to note is an increase. And she is earning, so this is our quantity, this much. There we go. So now that we have this annotated, we can easily use our percent equation. We have quantity equals percent decimal times our whole. And our quantity, like we said, is $22,680. And it equals, again, since it's an increase, what do I need to do with this 5%? I have to add it to 100%. I get 105%. And as a decimal, that's 1.05. In this equation, it says 22,680 is 105% of something. Let's figure out what it is. Let me plug it into my calculator for accuracy. We have 22,680 divided by 1.05, and I get $21,600. Does our conjecture hold true? Can we find the original value in a percent problem by using this formula? Yes, we can. So let's take a look at our criteria for success before we finish the packet. It says that for top quality work, the problem is annotated for the quantity, whole, and the percent change. So this is the increase, is the percent change. This is our quantity, and our whole is actually what we're solving for. So what was she earning before the pay raise? That's the whole. Let me write this down. CFS, annotate for quantity, whole, and percent. 2. Percent change is calculated and shown. That would be this guy right here. Percent change is calculated and shown. And lastly, it says percent equation is written and values are substituted. Percent equation is written and substituted. Looks like we did that. And that's how you find the original value in a percent problem.